We are happy to welcome you at the online lecture series from the NGS-CN Summer School 2024. As most of you already know, NGS-CN stands for the Next Generation Sequencing Competence Network. Our network has started as a DFG-funded national collaborative initiative in 2019, and up to 2023, there have been several annual calls for projects to be sequenced at our core genomic facilities across Germany. From 2024 on, you have a new exciting opportunity to co-apply with one of our genomic facilities for a high-cost sequencing project, which can cost up to 1 million euros. If you ask me, it's worth to check it out. Go for it. We leave the link in the footnotes, and here is a QR code for your fast access. Welcome aboard, find a comfortable seat, get a drink, and let's listen to our next speaker, shall we?
Hi, good morning, everyone. Welcome to day 2 of this summer school. And I'm Joseph. And this morning, I'm going to give a talk to the topic for basic coding concepts. And basic, it means we were talking about some introduction words about the coding. So if you are advanced already, just bear with me. And coding means that it is not something academic or knowledge-based. It's more like coding. Want to give you some idea how to hands-on and how to begin your learning journey. And concepts means that we are not going to ask you to write a code right now or to struggle with the syntax, do the debugging. No, we want to give you some concepts so that after this talk, after today, then you sit in your room tomorrow, then you have some idea how to learn by yourself, how to search for help, and how to begin your own journey to do bioinformatics. So yeah, this is the idea of the section this morning. And yeah, I'm in the genomic facility in RWTH Aachen University Hospital. And this is the picture of the hospital. And we have a team of 6 people. We are offering wet lab services and also bioinformatics services. And Aachen, you see, is on the very west, part of the Germany, just on the border. And today the talk will mainly covering 2 parts. The first part is about demonstration of the coding environment. When we talk about coding, you think, you just write something, but do you write it on Microsoft Word? No. So you need to have something to begin with. And so I want to introduce you some tools, some software, some program which can help you to begin. And then second part, we will dive into some codes, and I want to show you some way how we do coding to solve some bioinformatic problem, which you cannot do it in Excel. Okay, and I just give you a feeling that, oh yes, the computational power is really helpful for bioinformatic analysis. And eventually, I will also give you 9 good basic concepts when you start your way in learning coding. Okay, so and the first part we'll do by many presentation, and the second part we will use some Jupyter Notebook and to interactively show you the codes. And okay. And first, this is my own definition, my own word for bioinformatics. I would say bioinformatics utilizes computational power to process, explore, and analyze biological data with the goal of gaining deeper insights and understanding into biological systems. So our aim is something big. It's a biological system. It's not just one gene, one PCR experiment, just one. We aim to focus on genome-wide, the whole system. And then, but what we have is this biological data. Data means they are probably in a file, they are probably digital. And then for this, we need the computer, the computational power to do the job. So that's why we need the coding for bioinformatics. And then, but at the moment, you might think, oh, wait, I don't know coding. And this bioinformatic task is something terrifying, like a dragon. And you are excited to fight, join this fight, but some of you, not all of you, yeah, in reality, it is you now. You don't have the equipments. You don't have the armor. You don't have the sword. You don't have the shield. And then, so today, we want to help you to give you some tool, some weapon, which you can start to do your analysis, to join this fight. And so I just want to hopefully you have this vision that doing bioinformatics is something cool. And no matter how difficult you encounter later in the code, your learning, you need to, just as here you see, there's a very cool armor, very cool image here. And you need to bear this in mind. And so that step by step, when you learn, and you can just go through them, and then eventually you can get something. So first, I would like to talk about IDE and using the Visual Studio Code as an example. And what is IDE? So let's think about when you think about someone doing coding, and you may imagine that, oh, there's a guy sitting in front of a computer having many monitors. Yes, because he's supposed to do many different tasks. And some of them are like you need to do file browsing, and you need to edit the file, and you need a terminal, and then you need to do some visualization and even do some new tricks. And you need to be multitask at the same time to do many things. And you cannot just open different program, different window here and there. Eventually, it's not efficient. So there's a need for IDE. IDE stands for Integrated Development Environment. It integrates everything you need in one view, in one program, and so that you can see everything and touch everything you need. And usually, yeah, the IDE looks like this. You have several panels, and then each panel have different function. And so you can quickly select a file, add a word, or do some command. And there are many popular IDE, and Visual Studio is just one of them. I don't say it is the best. Everyone has your own favorite, but there are also like Python, Visual Studio, Eclipse, and RStudio, Positron, which is a relatively new one. And usually they have something like this. You have so here is just some explanation for the Visual Studio. You have the activity bar. Here shows offer different button. You can select different activity, and you have the primary sidebar, show the status of the Git branch, and also some error warning messages. And then C, you have this editor group. You have the panel where you can edit and type in the file. And then you have some other panel for like the problem output terminal and the status bar. And here we can quickly take a quick look. So yeah, this is a Visual Studio. Here you see the file. Once you click, you can see the content. And then once you are editing the file, you can still have a view of the file structure. And this is good because sometimes in coding, you need to edit many files, and you always need to keep the file structure in your mind and to organize them well. You can find certain thing, you can install, uninstall extension, and this is the benefit of VS Code because it has lots of extension you can install and then you can use, right? And then there are many things you can personalize, customize, and then here is the editor. You can edit a file. You can open multiple files at the same time. Yeah, and then here's the terminal. Yeah, you can do your commands here, right? So this is a basic view of IDE, right? Okay. And so I hope you all have this installed, and then with this tool, it will be easier for you to start coding. And then, okay, we have the demo. But VS Code is not a simple program. It has lots of buttons, lots of features. Very easily you get lost. And so I will suggest don't be too ambitious. You want to learn everything right away. You just learn, yeah, one thing at a time once when you need it. And it has a very good documentation. If you go to the VS Code documentation, there are lots of video, lots of documentation to teach you to how to do what. Okay, so hopefully, yeah, once you do use it, and you will learn it, yeah, step by step. So this is the IDE. Okay, and second, yeah, I would like to talk about the terminal and shell scripting. So now we have a tool, you know how to do the coding. And then now let's talk about some things, the interaction between you and the computer. So shell, what is a shell? A shell is a command line interface between you and the operation system. And let's see this diagram. This is your computer. The very core of this computer is the hardware. But the operation system has a kernel, and this kernel is a layer which interact with the hardware directly. And then upon the kernel, there's a layer called shell, and shell gives the command to the kernel, right, and to interact with the hardware. And then on top of shell, there's an application. So usually what you use in the operation system with graphical user interface, they are the application layer. So they are not shell. But with the graphical user interface, it is limited because you can only do what the designer designed the program, and you cannot do everything you want. So it's useful to learn shell because if you can do shell scripting, then you can directly command the kernel to do things what you want to do. Okay, and there are some famous kernel, famous shell like bash. This is what we are going to talk a bit today. And this is fish. It's just another shell, or Z shell. It's also a very famous one. And just they are different, but yeah, in most parts they are similar. Okay, but the bash is the most built-in by default in the most distribution in Linux. Okay, then this is a shell. And then what is terminal? Terminal is a program enable you to interact with shell. So this is how it looks like. It's just like a text editor, and then there's a prompt. You can start to write a command. And then this is a terminal. Just don't confuse them. Terminal is the program, but once you enter, you have this then it enables you to write the command to the shell. So terminal and shell. Okay, and now let's just do some demo together. So here I have some file. Okay. So here, yeah, just want to show you. So in the shell, yeah, you just have this. This is the terminal. So you cannot click or go up layer or click any file anymore. You have only a prompt and what you are going to do. And I want to just demonstrate you some basic commands, and it's easily to find many more tutorial online. Yeah, but here just give you some idea. Like this PWD is stands for present working directory. So you type PWD, then you will get an output, and it tells you where you are. So this is the path where I am. And I put L, ls, this is a list command. It lists all the files I have here. Okay, and then each Linux command, you also have possibility to add some parameter. And here we can say like even ls. L means we list the detailed list. And A means we list all the hidden file, all of them hidden as well. And here you see the output is different. Now it gives us more detail about the file permission, about the user, the owner, the group, and the size of the file, and the time of the modification, and the file name. So now you learn a bit now how we can use the command line to browse your data, your file structure. And now even you can change the path like cd, and then go upstairs, up layer. Now I go to my home directory. This is my home directory. Then I can cd plus a dash. Then I go back to where I was. Okay. Don't see. Okay, here. Yeah, I see it. Right, and then you can even make a new directory, like directory, new directory. And then
Joseph, sorry.
Yeah.
Could you answer a question once more? Here is Haif asking, are we going to have a workshop or a practical session? Could you remind people again what's your idea now about this talk?
Okay, yeah. So which question you are talking about? This one. Okay. So yeah, just briefly, just repeat what I said in the beginning. So this morning, we are going to just give you an idea and go through the environment, the tool, and about the basic coding concepts. And so that you can get an idea what you are going to learn in the future. But this morning, we are not going to guide you step by step, hands-on to work on your own computer. But here just want to give you some idea how everything works together. And later after the talk, I will send all the files to you and so that you can check them later after the talk. Okay. Yeah. And yeah, thank you for interrupting me for the question. Okay. So, and then here in Linux shell, you can also create a file. It's another command, called touch. And then you can touch a new file. And once you touch a new file, you see here, we create a new file and it's new. And then you can do things here, a new line, for example. And then let's go. No, sorry, I need to move around this. Okay. Yeah, and then there's a command called cat, which you can cat the new file. Cat means you print the content of a file. Okay, and so here I just want to demonstrate you that you can do many things with the shell. And you can copy a file, copy a folder, you can move a file, a folder, and you can even move many things. Like last week, I was organizing my photos, thousands of photos, hundreds of folders, and I want to extract every single photo from the subfolder to one folder. And if you do that manually, it might take a whole day, but I just do one command. I move everything from somewhere and to one place. Just one command, it does the job. And so, yeah, this is just a short example how powerful a shell is. But this is also, there's on the other side, it's powerful and it's also risky. So like this command, rm, this is the most notorious command you all need to be aware of. This rm means remove. So you remove a file, and then, or recursively, you can remove everything in a directory. And so why it is dangerous? Because if you have a typo, there's no way back. Okay, it doesn't go to trash can. It's just gone. So just be very careful to do this command. Yeah, and never do something like this, and it just clear everything in your computer. And so yeah, there are just some command. I probably won't go through all of them, but give you an idea how you can begin with the shell and how you can work on it. Okay, and the shell, this shell commands, and then the second thing is the bash, the shell scripting. And here, just teach you, so shell itself is also a programming language. And you can define a variable like this. You assign hello to greeting, world to name, and then you can print something like greeting name, and you will get, yeah, you will get something like, just type here and the echo. You got the answer. Yeah, like okay, here. You will get a hello world. So you can also do some base, coding, in command, and then in the shell, and then you can define a number, and then you can check this number is greater than 5, and if it's greater than 5, it output the number is greater than 5. If not, it says the number is not greater than 5. So there's just also some logic behind. And so that means using the shell script, you can also do something basic, and you can put all your codes together, in a file, and then you can execute them. So here I won't go to detail, but just shows you the shell scripting can also do many things. You can assign variable, do some calculation, wrap in a function, etc. Okay. Okay, then let's go back to the slides. Okay, and package management. Now you learn the IDE and you learn the terminal, and now you have an idea. You can write your codes in the file. You can using terminal to do something on those files. But what is package management? And this is something nowadays we usually face the problem. Like in this picture, it shows you that there's a fancy construction of this Lego. I don't know. And then, but it is not that stable because there's a certain piece. It's not that reliable. And this is what happened nowadays in the modern software or packages. So usually we all rely on other packages or tools and someone develop. And if certain things we want to replace or something is broken, it's easily break the whole thing. So this is called dependency hell. It's a situation where the software packages have conflicting dependencies, and it makes you impossible to install or update a small piece of them. So once I want to take out that small piece, and everything will collapse. And this is what happened like nowadays. For example, you install two program A and B, and A relies on Python 3.10, and B, now it says, oh, now we upgrade to Python 3.11. And if you just upgrade your Python to 3.11, then your program A might just breaks. And so this is why we need a package management. And now we just take Conda as an example. And there are many alternatives you can use, but Conda is a very popular one. I just want to demonstrate to you. And what is Conda? Conda is just like a hook here. Conda is just a environment manager. And once you install Conda, And by default, it will create an environment called root environment. And this environment, it install a Python version X and install some needed packages 1, 2, 3. Okay, now you have a project and you need a certain Python version. And then you can, using Conda, easily create another additional environment and then install another Python and install package 1 and 2. And then it's separate from the root environment. And then you just using, and then you can move your hook to this environment and using this environment. And then you work on project A, and later on you got a project B. Oh, and then you realize, oh, I need other packages. I need another Python version. And then you can just easily create another environment too. And then just move your hook to here, and then you can work on them. So the benefit of this is that you don't mix your environment. And then once your environment is stable for a certain task, you can just keep it as it is. And then once you need a new environment, you just create a new one. So this is the beauty of the Conda manager. And here, okay, also wants to do some demo. So this is the Conda environment. So I just clear the terminal. So once you install Conda, you will have access to the Conda command. So once you type Conda, it shows you all the subcommands you can have. And then here is you can check Conda version. And then it tells you, yes, you have successfully installed your Conda, and this is the version. And then you can update the Conda if you want. Yeah, and then by doing this, it will check, is there any new release of Conda, and it will update your Conda manager. And then here, I want to show you how you can create a Conda environment. Okay, just stop this. Do it. Okay, now Conda create with an N, with a name. We name it as my environment, and we define what Python version you want to install, and some other additional packages like NumPy, Pandas, yeah, and then okay, then you just type this Conda create everything, and it will check. It will go through the repository, find this Python release and all the other packages. And then it will, ask you, are you sure you want to proceed, create this environment and install everything? You just say yes, and then it will install, those packages into this environment. And once it is installed, it will show you to activate this environment, do Conda active my-env. So we can just do this way, Conda activate my environment. And now you see this is my command. I'm now in the base environment of Conda. That is the root environment by default. And then once I do this, now I jump to the new environment I just created. And then I can here do Conda list to list everything I just install. And you can take a look. These are the packages we just installed in this environment. And then we can even install more things like here. Those are things what we are going to use later. And Conda install, and then the packages you need. Right, and then it will go again, check the repository and then install them. So this is the way, a recommend way. Once you begin a new project, you need some packages and how you can create a new environment and install the packages you need. And right, so this is Conda. Yeah, and you can also remove certain things if later you don't need. Right. Yeah, and there are more detail. Okay. So I probably won't go through everything. Yeah, and so now I hope you got an idea how this Conda will help you. It can help you create and manage your environment, and so that you don't need to mix anything. And then you try something in the environment, and once you finish that, you no longer need this environment. You can just remove the environment, so that you don't mess up your computer. Yeah. Okay. So now I hope you are still with me. Now we have the IDE, we have the terminal, and we have the Conda for package management. And now when you actually do write code, yeah, in Python or R or something else, and this Jupyter Notebook is quite useful because it gives you a kind of interactive way for your coding. So here, Jupyter Notebook is something well support with VS Code. So this is what it does. So in the Jupyter Notebook, the file name called IPYNB, and this is the interactive Python notebook, and you have a different cell. So this is one cell, and this is a markdown. You can write text here, okay? And then you can write text, and then you can also write code. So, and this gives you the possibility that you can, when you write a code, you can write your note or some documentation or some explanation, and so that your code can easily be understood later on. Yeah, and then right away, like if when you open the Jupyter Notebook, you have to select the kernel. And the kernel is just a Python interpreter. And we can just use the environment we just created called my environment. And then once I do it, I can check if I type run each cell, I can run them. And the text part is easy, just print the text. But if you have a code, you can interactively run it. Like this chunk of code, it just do a simple addition. And then you can change anything and run it. And you got the output right away. Okay. And so, and this is helpful. When you write some code for your data analysis, you are just trying and you have small chunk here and there. Here, do one calculation. Here, make a figure. And then you can right away see the result and then go on and check it is right or not, instead of writing everything and then check at the very end. And then it has also a good visualization. You can print your figure right away. For example, here, I want to make a figure and just a simple figure to visualize all these data points. And then easily you got the figure at the bottom of the cell. And so this is very helpful when you are generating any figure, you have a chunk of codes, do a figure, and then you can see that right away. And then you can change something and do it, run it again. Yeah. And then you can also type many things like a list with a bold text, italic text, or some hyperlink. And the code is just by the markdown format. So it's easy to code. Right. So this is a short, demonstration to show you Jupyter Notebook. How you can use it and how useful it is. You can interactively write your code and check your results. So later on, we will use a longer Python notebook to demonstrate that. Okay, so now we are finishing the environment part. I hope now you got that idea. You have IDE and you have a terminal, and then you learn how Conda is important and how Jupyter is helpful for your coding. And now we want to talk about some real codes in Python. And why do we need Python? So first, we need to know why we need coding at all. So machine don't understand our language. So machine, the language of machine is binary, but we cannot talk with machine in a binary language. So we have to have something in between. And programming language is just like a bridge. And there are many different layers of the programming language. So on the figure on the right, you see that the level of abstraction from the bottom to up. So on the bottom, the language at the bottom, we call them more low-level programming languages, which is more for the machine, and it's difficult for us to understand or to write. But the high-level language is more close to our language. So that is how Python is popular, because Python is easy to code, its syntax is easy to understand, and then it has a big community, and it has lots of frameworks you can easily to use and apply. So yeah, highly recommend if you don't know coding yet, you can start to learn with Python. And there are many tutorial learning resources online, but I highly recommend this one, learnpython.org. It gives you some interactive panel. You can learn all the concept and syntax interactively. Okay, and now I hope you are still with me. And now we want to jump into touch a bit bioinformatics problem with the code. And then just want to show you how we have a problem and we want to solve, and how we can use Python to solve it. Yeah, okay. And then here, okay, now I open another file. Okay, so this part, so here I will do two parts. Part one, Python fundamentals. So if you are not familiar with Python, I will briefly go through some very basic, but not in a thorough way, so that you can follow me to understand the code. Okay. And then, yeah, Python. Yeah, in Python, yeah, you can import library. And library is just some codes or module people develop already and ready for you to use. And so you can import like matplotlib. It is a package for visualization. We just install in Conda. We can import it like this, and then import this package, this module as PLT. So we give it a name so that we later just call by this name, or from a certain package, we import a class. Yeah, and then this is import. What importing does, import just get some source of the codes, and then we can use them in your script. And functions. So when you write a code, it's good to put them together as a function so that you can separate your codes and manage them better. And then defining a function in Python syntax, we call define, DEF, and then we have a function name, and we have the input of the function, and this is the function body. We put all our codes here, and at the end, we return the results. So this function can be anything, and you just need to define it. Okay, and so this is the syntax of a function. And then the control flow. So in Python, you can have if statement. That means if something is true, and then it will do the following code. And if not, it will jump out. So like this code here, line is just a line in a file. And it checks starts with. To check this line in the beginning, it starts with this sign or not, the sharp sign or not. If yes, usually in the coding in many files, this is the sign for commands, for something, for explanation, for notes. So this is something you want to skip. So then it will just do continue. And so it will jump the line, start with the sharp sign. Okay, and then, and it not just have the if condition, it statement, it also have for loop. For means that if you have a list of the many elements, and you will go through each one of them. Yeah, and then for example, this line here, this example, you have a file, and this file might have 1,000 lines, and it will just for line in file. It will just iterate every line in a file to go through the whole file. And then, so now you get some syntax, how if works, how the for loop works. And then here in Python, there are some data structure. Here, I only show the ones we are going to use. So we have a list. So list is just a list that it contains many elements. And right, okay, this is, yeah, and then, okay, this line is probably too, yeah, let me open something. Wait a minute. Okay, let's see, list is just like this, 1, 2, 3, and then we got a list, and then we can check how many lists in a variable. Okay, so like this is a list. Yeah, so it's a bracket, and then inside you can put anything you want. You can put, yeah, you can put the text, you can put a number, and then you run it. It just count how many lists, how many elements inside, and then we can even print a list and show everything. So list is a very simple structure. And then, but another one we want to show is the dictionary. And dictionary is a structure with key value pair. So it's like this. So like dictionary, this is a dictionary. Let's say A key is to, okay, like A is the key and its value is 1. B is the key, another key, and its value is 2. And C is the third key and value is 3. Then if we print like this, give you the whole dictionary, but we can call the dictionary by its key. Let's say if I call this B dictionary and I want to give the key A, and then I will get 1, its value. So it's the dictionary. It has the key value pair, and the list is just a list of contain everything without the key value pair. Okay, so right, yeah, it's a dictionary. And then there's some string management, just some example of the code. Yeah, that this split is something, once you have a string, a long string, and it can split some certain character, using this correct character to cut them, to separate the string into a list. Yeah, later we will see the real data, and then you can understand how it works. And then working with file. Once you have a file, and then you want to open it in Python, and you need to do like this. You need to do with open and given the file path, and then say read as a file. So once you open a file like this, and then you can, using this file, to iterate it, then for line in file, and then to process the file. So this is just a syntax, just like when I come to Germany, I have to learn German language. And then I just need to learn all the vocabulary. I shouldn't question it's der die das, you know, why, this is what. No, there's not, it doesn't help me. I just need to learn it. So it's the same for all the syntax. Don't think about der die das. You just need to learn how it works. And then, so the matplotlib is another package, yeah, just for visualization, how you generate a code, generate an image. Okay, so I think I will jump to the question now. I think syntax we can add on later. So the example here is that I want to introduce you to a file called GTF. And GTF is called string transfer format. And it's a standard file format for gene annotation. Okay, and then what we want to do, and this GTF file includes all the information for genes, all information for transcripts, and all information for exons. And now I want to give you a task that not you, but you, because you don't have the codes now, but let's think about, now you are with me, no? Now we want to do one thing. In this GTF file, we want to count the number of transcripts per gene. Okay, each gene, how many transcripts they have. We want their distribution, that 10 transcripts per gene, 5 or 100, we want to know. And the second, we also want to count the number of exons for each transcript. So, I mean, this is a reasonable question, and now we want to check it. Okay, and how are you going to do? So now I just want to guide you step by step how we can attack this question. So first is create the environment, but we did already. I skipped this part. And now we need to download this GTF file. So in the Jupyter Notebook, if you put this line, yeah, this percentage sign with shell sh, and you will execute the code here in shell. Okay, and this is the way I just download a file, the GTF file from the database, and then I unzip the file. So I just run it now. Okay, and you see it start to download the file from the database. Okay, and it's going good. And then afterwards, it will unzip. Yeah, press extract this file from GZ to GTF. So let's see here. I got now a GTF file. Okay, so, okay, and then now we have this GTF file in my computer, in my directory. And this, now first, we need to understand what is the GTF file. And GTF file, we can read it by the shell command, the head. We only want to check the first 20 lines of the file instead of printing the whole thing. So once I do this, you can see the content of this file. The first few lines are some documentation which we don't need. It's not the data itself. It's just some notes of this data. What's the format, where are the source, and what is the date of the update. And then you see now below, this is the content of the GTF file. It has the sequence name, the chromosome, and it has its source, and it has the type. This is the gene, or this is a transcript, or it's an exon, and then the start position and the end position. So you can now see this is the very common file we bioinformatician handles every day. So you have the chromosome, position, and the type, and then there are some score and reading frame. It's not important now. And this is showing the strandness. So this gene is on the positive strand or on the negative strand. And then there are some attribute below afterwards here with some information like gene ID, and then with the ID, and then separate by a semicolon, and gene type, and then gene name. You know, there are many information. And so now you can see this GTF file is in fact exactly what we are going to use for answering the question. Because here we got the gene, and I mean gene line here is not that important, but we have the transcript, and then we have the exon. So we have everything. And now we just want to count, right? Each gene, how many transcripts, and each transcript, how many exons. So I hope now you can think about this question a bit, how you are going to solve it. How you are going to solve it. Do you just get all the gene name once or all the transcript ID once? But you might lose the connection to its gene. So we are not just do a total count of transcript. We want to calculate per gene or per transcript, right? So I hope you can think about it. Okay, now we understand the data, and then now we need to plan our solution. And so usually this is the part we need paper and pen to really think about our strategy. And here I just list some steps, which I want to show you. And so here the steps are, first, we need to load the GTF file. And we need to do this kind of planning before any coding. So otherwise sometimes you get lost. So we need to know what we want to do first. So we have the GTF file, and now, okay, I need a code to first load the file, read the file. And second, I need to read the file, GTF file, line by line. Oh, and I noticed that there are some lines on the top. I want to skip them, and they all start with a shape sign. Okay, I want to skip them. Okay, and then so I noticed that. And then second, I need to split each line. So GTF file is separate by tab. Okay, by tab in between. Here, this is a tab. And I need to separate them by tab. Okay, so split each line into its fields. So the chromosome, start position, end position, etc. And then, but the attribute part is not separated by tab. It's separated by semicolon. So it's a bit complicated. I mean, the data, it's usually complicated. And then, so you also need to extract that part. And you need to extract the gene ID and transcript ID. And then you need to define a data structure to store them. And then you need to count the statistics. And then after counting, you need to visualize the results. Okay, so I hope you understand this is kind of the plan, what I want to do for this short, small code. And then, right, and then, so after this planning, you need to start to write a code. And it's good to have a plan in hand so that you can just follow. Okay, now here I just want to go through this code with you, and hopefully you can understand. And later, after I share the codes to you, you can also try and see, play around. Yeah, but here I just want to explain and go with you together. So here we import some needed packages. And here we decide to use the data structure dictionary to store everything. So what it does, why? Because in the gene dictionary or transcript dictionary, we plan to have the gene as the key, and its value is all the transcript ID. So in this way, one gene name will have several transcript ID which match to this gene. And in this way, you are able to just count how many transcripts ID within each gene key. Okay, I hope you follow me why we decide this data structure. And the same thing for transcript. We have the transcript ID as the key, and then we have the exon as the value. And then in this way, we can, just count how many exons in each transcript ID. And so we got the statistics. Okay, then I need to go a bit faster now. So now we define the GTF file path. Here we open the file, and then we read line by line. We skip the line at the top, and then we split the line, each line. First, we strip. Strip means we just remove the space on the beginning or at the end. And split means we cut this string by tab and then put them into a list. So this fields is a list, contain every field in this line. And then we check if fields 2, this two means the third field is exon. Okay, that means here we only want to check the line with exon. Okay, we don't need gene and transcript because exons has everything. Exons, it has gene ID, it has also transcript. And what is important to us is the connection, the relationship between the exon and transcript ID and gene ID. So this is the important thing, and we don't need gene and transcript line now. Okay, and then here we got the exon, and then we focused, now we want to extract the transcript ID and gene ID. So we focus now on the attribute fields, which is the 9th field, above from this list. But those attributes, they are separated by semicolon. So we need to make another dictionary. And then for each attribute fields, we split by semicolon. That means after you splitting them, you got a pair like the key and the value, just like this one. Yeah, this is one attribute. After separating by semicolon, you have the key gene ID, then you have a value as the ID here. So this is what it does. It goes through everything, get the key and value from each attribute, and put it into this dictionary. And so in this way, I'm now able to call the gene ID from the attribute dictionary and say gene ID. Then I got the ID for gene. And the same, I got the ID for transcript. So now this part is how we extract gene ID and transcript ID from the attribute field. And then we add this transcript ID into the gene dictionary. So in each gene ID, all the transcript ID will be added into the same key, under the same key. And the same for transcript dictionary. Each transcript key will include all the possible exons. Okay, so then after running this script, it will go through the whole GTF file, put all the information into this 2 dictionary, and then we want to count them. So instead of just get the name, we want to count, all the number of how many transcripts and how many exons are in this dictionary. So this is what it does. It just gives us, just count all the sum of transcript or the sum of exon per gene or per transcript. And it gives us a list of the number. And then the following code, we just follow the syntax from matplotlib to generate the figure. Okay, so I hope you understand what we want to do. So I just run this script shortly, and it just does everything we planned. Okay, and you see, now we got a image and shows us the transcript. The x-axis is the number of transcripts per gene. And then this is the frequency. So, and this is the for transcript per gene. And on the right is the number of exons per transcript. But this doesn't look good because the scale is hard to read. So now we can also, if you check the matplotlib documentation, you realize, oh, there's a parameter. I can switch the y-axis to log scale. Okay, then let's do it. Here, the log. Okay, I change to true and true. And rerun it. Okay, then I hope, and look, this looks a bit better, more readable. You can see something below. So we turn the y-axis into log scale, and then you can read it better, and you see, wow, some genes have very few of them, has very high number of transcripts, but majority of them are like in this range. So this is a real data, and this is just something, you can really do just with a small piece of code. And then now but I want to just show you a bit step further. So we talk about function, and now all your codes from top to down, you do one thing, but it's also wise to wrap them into different function. Like I wrap this part of code parsing GTF in a function called parse GTF, and this function just input the GTF file name and output to dictionary. So this is exactly what we just did. And then we also put this part of code parsing the attribute as another function, and also the plotting in matplotlib as another function. So we just reorganize our codes, and eventually we just got these 3 lines. We just give the GTF file path, and we can parse them, and we can plot the statistics. And this is more clear way to do, because each function is well defined, and then also in the later on, you can easily apply to any other GTF file. So you see the beauty of this. You don't need to copy and paste the old codes again and again. You just define a function, and then you can just rerun this function, whenever you want to do, and even apply to any other new files, and it will does exactly the same thing. Okay, and now I want to show you, but this one, okay, now you got the results, but you probably are not satisfied because it doesn't look good. And now I just want to show you with a simple change, the Python code can really do a good figure. And here I use Seaborn, and there are just some code, some small modification. But we can make the figure Yeah, much better. Yeah, so I just want to show you, yeah, it takes a bit longer when we first time import a certain package because Python needs to compile it, but it will go faster later. So, and look, this figure looks nicer. Yeah, and so just want to show you it's possible to do yeah, good figure and good statistics just with Python with a small piece of code, right? And okay, so this is the demo. I hope I convince you that we are able to use the Python code with just some basic knowledge and to work on some real data and make some meaningful figure. Right. And now at the end of this talk, I just want to talk about 9 basic concepts which might help you in the future when you learn. And then I hope before 10:20, we can go to some questions. Yeah. Okay, first, problem solving and algorithmic thinking. So when you have a problem and you need to analyze that problem, when you want to solve a problem, you need to break a complex problem into some smaller and manageable tasks, and that help you to write your code. That is what we just did, that when you define a question, a problem, and then you need to really plan, think, not yet coding, but really think how you want to approach this problem logically. And then after you break it down and the task becomes smaller, and then it's also easier. And then you can just write different codes to solve them one by one. And then once you solve all the small problem, and then you solve the big problem. So this is very important. We need to learn this problem solving thinking. And second, we need to write clean and maintainable code. So writing code, it's now easy. You get some code from online or from ChatGPT, and then you can just copy and paste, but make sure you understand it. And you understand it, and you also need to make sure yourself in the future will understand it again. So the advice is we write for humans, not for machine. So all the variable name, the code, how you structure, you need to write for human to read, not just like everything call them X or Y, A, B, C, and eventually you don't know what is what. Yeah, so write clean and maintainable code. You might think, oh, now I don't have time, but no, eventually will save lots of time in the future, right? So writing a clean and maintainable code. And then third, you need to test your code. You need to learn how to test the code. So the code, when you write just a few lines, is something obvious. But when you write more, and sometimes you're confused which part does what. So you need to learn those in Python. There's a assert statement which will check yeah, certain file or value is what you expect or not, or the unit test is something bigger. I hope, yeah, you all can learn in the future when you're more advanced. And then by doing this, you automatically do the testing in your code. Yeah, and to make sure the quality, the output is correct. And then you also need to learn debugging. So we never have intention to put bugs in our code, but it always does. So we just need to learn how to debugging and to handle the error. So like a quick print command in the Python code to see the variable, or try and accept blocks to help you to handle the error. So this debugging is important. So this is also a skill. If you learn it, and you will do it faster, yeah, later on. So this debugging is something, yeah, we shouldn't ignore. and also the command line. So command line, we just demonstrate to you that how you can navigate yourself, but it's very powerful. So you also need to learn how to do things efficiently, right? And yeah, just believe me, there's always something you never heard. And you just learn it little by little. And this is a good figure that, yeah, when we begin, I mean, not as a coder, when the number of tasks grow and the time you spend on solving them also grow, and because you do everything manually. But if you spend some time, yeah, to learn how to approach something, we use writing programs. You might, spend some time, stuck somewhere here, so having some delay. Yeah, like here, does it manually together when the size are small, but once you get annoyed, this is stupid, I don't want to do it manually anymore. Then you start to Google to find solution, and you write scripts to automate those tasks. And there might be some delay. You spend some time here, but later on, you just run the script. No matter this text size grow to what size, you just spend the same time and just run the script. So you need to have this mind. It is worthy to learn the command line and learn more programming. Yeah. So, and then, but when you write a program, a function or a script, you want to do something, you need to learn also a bit the code optimization and efficiency. And what I mean is this big O notation. And this big O notations shows the complexity of the of the code. And so I won't go detail here, but just keep everything, yeah, most of your code in this kind of area, like n log n or just n, yeah, or log n, or just very, yeah, not too complex. Once you go here, and the codes will take so much time and it's not practical anymore. So the big O notation is worthy to learn to get a concept so that you won't go to a dead end, right? And then the version control. So Git and GitHub is something you have to know, and then to know some simple command about Git so that you can manage your code in a better way. Otherwise, sometimes you do something and then later on you realize, oh, I want to extract my old codes last week, and then but you don't have them anymore. But with Git, this version control, you can always go back and to check what you did before, or another version, another branch. So it's very convenient. And 8, the file management and processing. So for bioinformatics, there are lots of file formats. And here I just list some of them. It's not a thorough list, but you see there are so many things. We just touch one of them, GTF here. But there are many other different file formats. And you just need to, you don't need to remember them, but you need to understand them and then know how to read them, how to write them, and how to manipulate them. And so you need to know the file from bottom up, yeah, and not just trust a program, and that program you expect it to do everything for you, so you don't need to understand the file. No, it's better to understand them, and you can manage them. And this is on the file level, but also the last point, yeah, we need to learn a basic project management. So you need to have a well-structured project folder. So like this figure showed, this kind of file project management like this desktop is something no go, because eventually you have no idea what this code file for and what it does, and the folder is not clear, file is not clear, and everything you wrote eventually becomes useless, and that is not helpful to anyone. So you need to learn how to manage your project, how to name your folder, how to name your file in a reasonable way. Yeah, and so that's the 9 tips I would like to give. So yeah, hopefully, yeah, thank you for bearing with me. So yeah, I hope today we equip you something and you can start this fight to get now. And through more learning and practices, you get stronger and experience. And the dragon, this terrifying dragon, all the complicated problem becomes less terrifying. But you might not conquer it right away, but just keep fighting, but also at the same time enjoy your journey in bioinformatics. Okay, and thank you. This is my talk in the morning. I'm now happy to take any questions.